Good.
Awesome. Thank you.
Um, so I'm going to begin by telling about our development of the Assessment of Student Knowledge of Green Chemistry Principles, or AskGCP for short, because if you want to know what students know, you need to ask them. And so we started this because when you look at literature, a lot of the reports talk about how green chemistry has been incorporated and how to teach it. But when you look at how it's being assessed, only 11% actually report the impact on the student learning. And when they do, it's typically just a single group post-test only research designed for being predominant. And so what our goal was just to develop an instrument that was quick to administer, that could be readily used by faculty around the world, and that would be able to measure students' knowledge of green chemistry. And so the way we did this was we started off by developing 72 items that were written by 5 people here. And we followed the best practices for red and true false items. And from those 72, we picked 24 that we felt best representing each of those principles, so that each green chemistry principle was assessed by one item whose correct answer was true and one whose correct answer was false. And then we took that pilot version and we administered it out to our students with the clarification of prompt of, is there anything of this that's wording that's confusing? And we got some feedback, which resulted in us changing 2 of the prompts. One being that students didn't like the word ambient, so we changed that to room temperature. And then another one being that they didn't like the words halogenated molecules, so we just says molecules that contain chlorine, just to kind of make it more clear for the students. And so that resulted in our final 24 item true false assessment. And we included the option don't know, so that students aren't forced to guess true or false, so that if they don't know, you can very quickly see which ones they're indicating they're not sure on. And so you can kind of just see what the items are that we used. And so we then assessed the instrument for its reliability, validity, and stuff, which you guys can see in the paper. But we also wanted to see if it was sensitive to intervention, so that it could be used for pre and post test. And so within our major section here at NDSU, we did 2 different projects. The first one was we had students create green chemistry infographics. And then in the spring semester, we had those same students create an OER webpage where they analyzed the reaction for the greenness for OChem 2. And what you can see here is that there was a very significant increase in the one for our first intervention, but it wasn't significant for the second, which was likely due to the fact that these students had already been well exposed to them in the fall semester, so they had already learned it. But you can see that it is sensitive to being able to be used as a pre and post test. And so then we also did what's called a rash analysis to generate what this figure is as a right map. And so on the left-hand side, you can see for student abilities. And so it starts from student abilities for the low scoring all the way up to the high scoring students. And then on the right-hand side of the map is the difficulty of each item. And so the difficulties match the student ability for where you have a 50% probability for a student at that ability to get the answer correctly. And so you can see that their wide range of items approximately match the student ability, so you can actually measure different abilities of the students. And also, the ones where the correct answer is false across the board are more difficult than the ones that are correct answer is true, which matches with literature where a lot of times they do say the false items are more difficult for students to identify as. And so if you are worried about ceiling effect or stuff, you could chop out some of the easier true and keep more of the false items. And so for implications for practice, as I said, we developed it to be quick. It took most our students less than 10 minutes to complete. You can either do it in class, or a lot of times we just administered it online so our students could do it as homework outside of class time. And so, like I said, we did it online. Usually we used Qualtrics. We also did one impromptu time where we just did paper and pencil with some students. So you can use other methods. Qualtrics is really nice because you can have Qualtrics score it for you. So you get the list of scores along with the list of which principles they are missing. So it's kind of nice that it does all that work for you. We do recommend it be used for formative assessment and not graded, especially so you can actually see what students don't know. So they're not guessing, they'll actually mark, not, I don't know this. And so it should be taken as something low stakes. And then it can be used, as I showed you, as a pre and post test because it is sensitive to actually measuring those learning gains.
All right, and now I can start. So, so the instrument is published as well as can you hear me, right?
Yes,
Okay.
we can hear you.
The instrument is published in SERP, so you can access the instrument and feel free to use it, as well as the interventions are described in separate publications. And the idea that I wanted this instrument to be a way to measure students' knowledge about green chemistry, but not the only measure of students' knowledge of green chemistry. So it can be used to in conjunction with other measures. Or for example, if you want to do a qualitative study and interview students, so this instrument gives you a range of abilities with respect to knowledge of green chemistry. So you can select a really diverse representative sample and not just people who sign up for interviews, who are usually high achieving people, high achieving students. So as any true-false instrument, it has some drawbacks. And of course, the first one is that it's quite sensitive to the impact of gassing. Generally, true-false items are good for testing lower order cognitive skills. So on Bloom's taxonomy, that generally towards remember, understand, and apply. Usually they are not really instrumental in measuring higher order cognitive skills. And since the items can be, especially as students learn, green chemistry items become easier. And you have the quite good saturation for items with the lower ability, but you don't have items that measure higher abilities. And with that, we were looking also for alternatives for this one. And one of the assessment tools that we explored is previously reported by Anne Berenger in her publication. And so the prompt is given here. So it's basically asking students an open-ended question where students compare two reactions and try to make a decision which one is greener about two abstract reactions. So this type of assessment is quite good for measuring gains in knowledge, because due to non-content nature of that, it can be administered as a pretest. We also found that it's quite sensitive to interventions, and this one does not appear to have a ceiling effect, as opposed to the Ask GCP instrument that Crystal talked about. This one is hand graded, so you basically have to read all of the statements that students come up with. But we found the format that is really easy to score. So basically, give students a table and ask them to put the statements in the separate cells. And as open-ended question, this one can provide deeper insights into students' cognitive structures about green chemistry. We did some preliminary work with exploring how this prompt functions. And again, this is a right map now generated from open-ended responses. And here, what we found that the two things that students are more likely to mention is that they most often take into consideration this safer synthesis. They try to eliminate waste that is produced by synthetic pathways. And they also looking at some various aspects of energy efficient reactions. So, and other green chemistry principles or statements that relate to other green chemistry principles are less likely to be mentioned. So they appear as more difficult items here. So we were also interested how students are able to apply their green chemistry knowledge with respect to the specific organic reactions. So that's why we designed the more modified versions of this prompt, which uses specific examples. For example, here's an example that we used in our recent study to evaluate students' knowledge after completion of a case study. So there are two epoxidation methods, and basically we ask them which one is greener. And this one is administered as a part of exam, so students don't have access to Google and other tools to help them make the judgments about that. Of course, those kind of prompts can be analyzed for what statements students get correct or incorrect. But we also found that they can provide insights into students' ability to make arguments. So we use the Solow taxonomy, structure of observed learning outcomes, and we try to map students' responses with various levels of the Solow taxonomy. So here you can see that this one is hierarchical. So it starts with the pre-structural, so where students only say yes or no, which one is greener. So it can be unistructural when they address one or two green chemistry principles, and most of the students were at that level. So in some higher order cognitive structures, we observe when students mention at least 3 green chemistry principles, and they discuss pro and cons of all of them, and sometimes they even suggest the modifications to make the reaction greener. And some advantages of using this reaction comparison prompts, both content dependent, as I showed with the elucidation example, or content independent, the one that Anne Berenger used. So you can tailor them to the specific organic chemistry reactions. You can design the prompt in a way that will elicit specific green chemistry topics that you addressed in your instruction. They can tell you what students know. They can tell you about partially correct ideas, and they can tell you something about student misconceptions about green chemistry. When you design this reaction comparison prompts, you can decide where you want to have one answer that is obviously correct, and all of the aspects of one synthetic pathways are greener than other. Or you can design prompts in a way, for example, that such as Shigufa we're talking about, in a way that there might not be a clear winner. And in this case, the prompt becomes more instrumental in eliciting students' ability to build a good argument as opposed to what they know. So, and finally, so I modified this slide as I was listening to today's presentations. So if you couple this approach with any other metrics that discussed today, such as Green Motion tool or resources from Pharmaceutical Roundtable, you can use this approach to measure students' ability to analyze and interpret data, which is one of the science and engineering practices that is a part of the NGSS. Okay, and finally, try to make it short. So some takeaway points. So in general, there is a need for some set of assessment tools that can tell you something about green chemistry knowledge that is possessed and acquired by students as a result of exposure to different green chemistry curriculum. And we discussed two somewhat distinct ways. So Crystal, we're talking about Ask GCP, which can be an efficient tool for quick administration, for large enrollment classes, or for screening. And you can also use open-ended prompts to make inferences both about students' knowledge and about the reasoning ability. So I think I'm done.